In section 8.3, we are going to do some more with multiplication, but before we do that, we're going to take a little quiz. What I like, just a little formative quiz, nothing that's going to go in the grade book or anything, but if you are watching the video, you should pause this until you're done with all, actually we're only going to go up to number 3, so when you're done with those first 3, you should go ahead and come back and check it. So when we are doing multiplication, remember this is just a strip property, so we're going to multiply the side of those parentheses in, remembering that every 2 negatives makes positive. So in the first one, we have 1 negative, we have a 2, we have an x, and we have 2 of them and 3 of them, which is not 6. It'd be 2 x's and 3 more x's, giving us x to the 5th. On the next one, still just 1 negative, so we'd have a minus 5, x to the 4th, and on the last one, minus 6x. Make sure you put that little 1 there so you can see that you actually have 3 of them. All right? Next, we need to know from the previous section how to find a GCF. The biggest thing that I can yank out. Notice I'm doing the opposite of what I did in number 1. In number 1, I hopped it in. On number 2, I'm going to pull it out. What's the biggest thing I can pull out front of the parentheses? And we can see that that would be a 4. I can divide out of everything. How many x's can they each first afford to give me an x? And they do. I'll have x's in them. And then how many can they afford to give me? And just 1. So then I'm going to divide every term by 4x. Divide by 4, I get a 2. Divide out an x, and I get x squared. I have a minus. Divide out a 4, I get a 3. Divide out an x, and I get an x. Again, I'm just dividing this out. Here, I multiplied it in. On number 2, I'm dividing it out. And then again, at the end, when I take that 4x and divide it by 4x, make sure you put a 1 here. Those are very easy to check by just hopping it back in. And number 3. That one actually just said, what is the GCF? I went too far on it. The GCF is 4x. Number 3 asks me to do what I did in the previous one. So, what's the biggest thing I can pull out of each of those? A 5. How many x's can they give me? You can give me 4, you can give me 3, but you can only give me 2, so I have to go to the lowest one. Then, I divide that out of every term. Divide by 5 and I get a 1. Divide out 2 x's and I have 2 left. Divide out of 5 and I get 3. Divide out 2 x's and I have 1 left. Divide out of 5 and I get a 2. Divide out that x. And I'm taking x squared out. Sorry, I wouldn't have any of them left. And it's done. Alright, so check those. Next up, we are, gotta go back a page. We are going to multiply 2 binomials. So let's review why we call this a binomial. It's because we have 2 terms separated by a plus or minus. So it would be because it's a 2-termed polynomial. And then it says consider. I'm going to be multiplying this by this. Notice there's not just one thing to hop in. There's 2 things to hop in. And we're going to do them in a specific order so that we can use an acronym to remember them. So what we do is we call this the FOIL method, and then anybody in a higher level of math would know exactly what you mean by the FOIL method. We do kind of what's most natural. They just put words to it. So first of all, I'm going to ignore that 5 right here, and I'm just going to multiply the first terms. First in this chunk, first in this chunk. So the first terms are 3x and x. Then we have to talk about what the outside terms is. When we talk about the outside terms, we mean the ones on the outside here, not squeezed in the middle. So we'd say a 3x and a minus 2 are considered the outsides. Insides are these 2 squeezed in here, the 5 and the x. And the last terms, what I mean by last are the last 2 in each of their binomials. So I don't mean this and this. I mean last in this one and last in that one. So it'd be the 5 and the negative 2. And so when we use the FOIL method, really what we're going to do, I'm going to rewrite that up here, it was what? 3x plus 5 times x minus 2. So 3x plus 5 times x minus 2. We multiply in exactly that order. We do firsts. 3x times x is 3x squared. I'm going to put a little f over there for first. Then we go to the outsides. 3x times negative 2 is minus 6x. Then we go to the insides. 5 times x is 5x. And then we go to the lasts. 5 times negative 2 is minus 10. And then if these combine, we combine them. So we've got firsts, outsides, insides, lasts. So we have 3x squared minus 1x minus 10. And again, you don't need that 1 there if you don't want to put it. So now we're just going to go do a little drill and practice here. We're going to use the FOIL method on each of these. The FOIL method is really just distributing. You distribute the 4x in here, and then you distribute it in the back. And then you distribute this in, and then you distribute it to the back. So really what you're doing is just the distributive property. But we call it the FOIL method because of the order that we multiplied it. Firsts, 4x times x is 4x squared. Outside, and again we're multiplying each of these. First, outside, inside, and again I'm multiplying, so no kind of a 9. I've got a negative times a negative giving me a positive 20. I've got to make sure I always CLT and combine those like terms. So I've got 4x squared, I'm down 20, I drop 4 more, I'm 24 degrees below 0 if you think of temperature, plus 20. So there is my FOIL answer. One more together, here we go. We do firsts. 3x times x is 3x squared. We do outside. 3x times 2 is, it's kind of easy. I'm talking fast, but FOIL method is usually not something that gives kids much of a problem. Negative 4 times x is minus 4x. And again, the only mistake I see sometimes is people like to add these last words. Multiply, 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 multiply. Multiply first, multiply outsides, multiply insides, multiply lasts. And negative 4 times positive 2 is a minus 8. I'll lump these two together. I'll get 3x squared plus 2x minus 8. If we were in class, I'd have everybody go to this one. If it looked good, I'd quit with the notes. So I'm going to assume it looks good. And I'm going to head on down to this last one here. Something a little different happens with it. I am going to, these are just in case extra practice is needed. So let's go take a look and do our firsts. 3 times 2 is 6. P squared times p is p cubed. Outside would be a minus because of the one, negative 15. P squared. Inside is going to be a positive because they're both positive. 3 times 2 is 6. And my last 3 times 5 is 15. You'll notice the difference with this one is that on this one, the O and the I are not combining because they're not like terms. All that means is I'm done. But I'll tell you 90% of the time the O and the I combine. I'd like you to kind of analyze the different one and tell me why of all of them this one didn't combine. That'd be a good question for you to be able to answer that. Why would we think that this one, if they aren't combining, it has to do with this power versus this one being different? Here it's first degree, first degree, first degree, first degree, first degree, all the way on up. But when the degree of that lead term changes, that's when we get terms that don't combine. But most of the time, they will. So that's kind of nice. So let's see. Day 2. All right, so we are on, I think I might just do 8.3 day 2 here while I've got the video on, pretty short one here. So normally what we would do here, if you were watching this in class, is we'd work on a worksheet for a little bit and then we'd tackle a new skill. But let's answer this. How do we multiply 2 binomials? We FOIL. Basically that's the distributive property. Well, what do I do when I have a binomial and a trinomial? 2 terms by a 3 term. We actually do the exact same thing. The only thing is that it doesn't spell the word FOIL because what I'm going to have to do here is multiply this into everything and then this into everything. And I don't really have an acronym like FOIL that I can apply to it. I just simply call it the distributive property. And when I'm done, I make sure that I've combined all my like terms. So let's go do that. I am going to erase this, and we are going to just pretend that minus 2 wasn't there, and I was just hopping a 3x in. 3x times x squared is 3x cubed. 3x times 4x is 12x squared. Put these in color-coded here. And 3x times minus 1 would be negative 3x. Then you pretend the 3x isn't there, and you multiply the negative 2 into everything, and you just watch your signs. I get a minus 2x squared on this first top right here. I get a negative, because of only one negative, minus 8x on the second hop. And my last hop, I've got a negative times a negative, giving me a positive. Now I'm going to go combine all my like terms and make sure my answer is in standard form. I end up with 3x cubed. I've got 12x squareds here, and I'm removing 2 of them, which gives me 10 of them. I'm down 3x, and I'm dropping 8 more, which puts me down at 11 x's. And then I have a constant term at the end of 2. And it's done. So, one more, and we will continue on. So on the next example, again, there'd be one in class where you try it, and I'd walk around and check it, and if things were good, we'd move on. We'd stop and adjust. But with the video notes here, I've just kind of got to do it for you. But I suggest you pause, you do it, and then check it. So what am I going to do? I am first going to distribute the y in. So I'm going to go this, then I'm going to multiply this, then I'm going to multiply that. When that's done, I'm going to distribute the negative 3 in. So I'm going to do this, this, this. So I'm basically doing 6 multiplication problems. Let's go do those blue ones first. Let's go hop that y on in. Hippity hoppity. We've got 2. Y to the third, because there's a 1 on that one. We've got y times y with one negative sign, giving us a minus y squared. Then we've got a plus 6y. Then we're going to go and ignore that first term. And we're going to go hop that negative 3 in, giving us a minus 6 y squared. A negative times a negative gives us a positive, so we will have a plus 3y. And on the end, with multiplying them, we get a minus 18. We're going to combine our like terms. We've got 2y cubed. We're down y squared, down 6 more, we're down 7y squared. We've got 6y and 3y, giving us 9y and a minus 18. So really, this section is pretty straightforward with the multiplication. It's kind of nice, not generally a whole lot of problem areas on here. So let's go take a look at some word problems that go with this. Primarily, they're geometric in this chapter, so you have to know stuff about rectangles and squares and that kind of thing. So it says you want to create a border of length x around a rectangular skate park. So let's go do that. This is 50 by 20. That's 50 that way. That's 20 that way. And I'm going to put a border around it. You want to create a border of length x in a rectangular skate park, which is really right. All right. This should actually say create a border of width x. What that means is you want it to be x amount. It's not good wording on that one. So what that means is we want to make sure that it goes x this way and x this way on all these corners. So it's x that way and x that way. Same here. X out, x down. So it's a width of x. And it says write a simplified expression for the area of the park. Well, again, area of a rectangle should be locked in your brain. We do base times height. All right, so let's go down to this base and let's talk about how long this new green base is, because it used to be 50, but I went out x and another x over here. So I took a length of 50 and I tacked on x and another x. That's not 50x squared or anything weird. Let's pretend it's a number here first. Suppose that was 3. You would automatically say, well, then it's 56. You went 50 plus 3 plus 3. Well, 50 plus x is 50 plus 2x. Let's go write that on there. Then my height, likewise, it is right now 20, but I tacked on an x and another x. And 20 plus an x and another x is simply 20 plus 2x. And when I multiply this binomial, 2 terms, by another binomial, I FOIL firsts, outsides, insides, lasts. Then I want it in standard form, just because I feel like it. And I want everything combined and simplified. So I'm going to lead with my highest degree, or highest power, which would be 4x squared. I've got 140 x's, and then I've also got plus 1,000. All right, now this next problem right here I'm going to tell you is for those of you who would like to have access to the enrichment, one of two enrichment questions on the test. What that means is we expose them to you to them and we teach them to you, and we do put them on the test, but they count as extra. So if they make you uncomfortable and they're a little beyond the scope and sequence of this course, they would be more like in a typical Algebra 2 class, and just taking what we've learned and kind of stepping it up a notch for maybe some of you who need a little bit more challenge. So if your brain is full, you can go ahead and quit right here. But I'll tell you on the test, we put a very similar one to this. It's not multiple choice though, so there can't be any guessing going on. So I'm going to walk you through it. And if you are feeling at any point uncomfortable with it, just stop. If you think you got it, might as well keep going because we'll put one light on the test. So we've got a cylinder off over here like a soup can, and I am supposed to figure out which one of these gives me the surface area. And you might be saying, well, how the heck do I know all the formula for surface area? You don't need to. We will give it to you. So whenever you're given a formula in math, you should write that formula out and realize that you will be, I'm going to write that out here, replacing all the variables. 2 is a number, pi is a number, say a rational number, 3.1417, etc. R is a variable. So R is going to be getting replaced in this formula. Number, number, variable, variable. So what that means is it varies from cylinder to cylinder, but all cylinders will have that 2 pi in their surface area formula. So let's go take a look at what we need to do here. You'll notice all the x's and r's aren't in here. They're all x's, and that's because our radius is x plus 1 and our height is x plus 4. So we're going to go replace those in the formula. So what we've got here is 2 pi times, and here's what I would suggest. Well, I think I'll just write it out here. We've got 2 pi times r. Well, the radius is x plus 1, and we're supposed to square it. So there's my 2 pi r squared. Plus, in the formula, there's a 2, a pi, then we've got r, and we've got h. Now, there's a couple ways you can approach this. I'm going to take you on the easiest route. All right? I think the easiest thing for you to do is pull that, oops, sorry, that should have been an x plus 4, I wrote x plus h, right? The easiest thing I think to do is to take that 2 pi and just pull it out, factor it out. It's in this one and it's in this one. So we're just going to yank it out front, totally legal. And then we have x plus 1 squared, and then we have an x plus 1 times an x plus 4. So you'll notice what I've done here is I've taken this 2 pi and I factored it out of both. I actually could have even done it right here. So, you know, it's common to both terms. I can pull it out and factor it out. Then I'm going to go and FOIL both of these. You might say, well, there's not 2 of them here. And I'll say, yes, there is. Really what I've got going there is x plus 1 times x plus 1. So I'm going to keep that 2 pi just hanging out front so it doesn't get in my way, and I'm going to go FOIL these 2 firsts. Outsides, insides, last. And remember, we're multiplying those last. It's 1 times 1. That just took care of that one. Then I'm going to go over here and do the same thing. Firsts, outsides, insides, lasts, and I'm multiplying those. Then what I'm going to do is go clean all this up. I've got x squared plus x squared giving me 2x squared. I've got x and another x for 2 of them. And then I've got 4 more, so I'm at 6 of them. Then I've got another one, so I'm at 7 x's. And then I have plus 5. Now I'm going to deal with that 2 pi. And so I think it's best if you pull that 2 pi out and deal with it at the end. Notice I'll get 4 pi x squared. And even for multiple choice, I know what the answer is. But it's not going to be multiple choice. But it's good to get used to those tricks of the trade in multiple choice because a lot of your standardized tests are like that. So I won't even continue with this problem. I'd circle C. But for your test, I'm not going to make a multiple choice. So when I multiply that in here, I'm going to get 14 pi x. And when I multiply it in here, notice I get 10 pi. So it is C. But you're going to have to come up with that from the start. Now this looks like math vomit up on my screen, but keep in mind, this is only for enrichment. This is for those of you who need a little extra challenge. If you can't do it, no worries. On the homework, it's optional and extra credit. And on the test, it can only add to your score, not detract from it.